This is problem 17 of chapter 17, and it's a continuation of problem 13, which I also made a video of. But here they're changing the situation on us just a little bit. They're telling us that the sample size now is 12, and they want to know the probability of right-handers. So the probability of a right-hander is going to be 1 minus 0.13 because it was 13% in problem 13. So anyway, that's going to be 8.7. Okay, so everything we did to confirm that this is a Bernoulli situation and binomial problems are still satisfied. So we're in good shape there. To find the mean, the expected value, we need a random variable. So we're just going to say let x be the number of right-handers. You could say selected or whatever. So let's see, the expected value of x is just n times p. So that's just going to be 12 times 0.87, and I believe that's going to be 10.44. And the standard deviation, SD of x, is just the square root of NPQ, where Q equals, I wrote P, where Q equals 1 minus P. Alright, so the standard deviation then is going to equal the square root of 12 times 0.87 times 0.13. That comes out to be 1.16. Okay, so that's how you do A. You just have to know these formulas. Okay, this one and this one. Okay, so now B, what's the probability? So before we get going too far, let's build a probability model. And this is how I draw mine. The Khan Academy videos that Khan has, he draws them slightly different, kind of like histograms. But I'm going to draw mine like this, because what I'm really using this for is I'm not so interested in these probabilities. I mean, I can get them on the calculator, but what I want to use this for is to help me sort through the questions. For example, B. What's the probability that they're not all right-handers? So I guess I'm just a slow thinker. So X is the number of right-handers, so this is 0, 1, 2, 3. So that's all of them. That's X less than or equal to 11, right? So that could be just 1. No, that's just binom C, D, F. We just accumulate all of these. Okay, so you could do binom CDF, and we would go 12, 0.87, and 11. Okay, that's one way to do it. Now, if you had the table filled out, you could also go 1 minus probability of x equals 12. Use the complement. So I don't have that right there. If I wanted to get it from the calculator, I'd say binom PDF. No, yeah, PDF. So I just the 1, 12.87, and 12. And I would get the same thing. So let me just do this real quick. Binom 87, comma 11. So I get point, up here I get point 0.812. Okay, and if I do binom PDF, I bet it's going to be a pretty small number. Binom PDF of 12, comma 0.87, comma 12. It's not as small as I thought. It's going to be 0.1880. So turns out to be the same number, obviously. Okay, so that's how, there's two methods for doing that one. Let's see. C, what's the probability that there are no more than 10? Okay, no more than 10. So that would be from 10 back. So that's the probability of x less than or equal to 10. Okay, so that's just binom CDF of 12.87 and 10. Okay, so let me just check that. So I put in a 12, comma 0.87, comma 10, and I get 0.47. I get 0.47480, or approximately 47.5%. Okay, a couple more real quick. Let's look at D. What's the probability that there are exactly 6 of each? Probability that there's 6 of each. 6 left-handers and 6 right-handers. No, 6 of each. What's the probability that there are exactly 6 of each? That's weird. The probability of x equals 6. Right? Because you'd have to have exactly, this is kind of weird, but there's 12, right? 12, and if you had 6 left-handers, then you'd have to have 6 right-handers. So they're just messing with us here. So that's just binom PDF of 12.876. Okay, so that's going to turn out to be a small number, 0.00193. Okay, so we got time for a little more abuse. What's the probability that the majority is right-handed? Okay, so what's the probability that the majority of is right-handed? So that would be you'd have to be greater than 6, right? Greater than 6, so greater than or equal to 7. Okay, so now I can't do that on the calculator. I can't do greater than or equal to 7, so I want all of these numbers added up. So to do that, I'm going to have to do 1 minus the probability of x less than or equal to 6. So that's going to be 1 minus binom CDF of 12, comma 0.87, comma 6. Okay, and let's just do that real quick. Okay, put in a 12, comma 0.87, comma 6, and I get 0.002263998. So if I subtract that from 1, I get 0.998, or 99.8%. Okay, so some of the questions here are a little tricky to understand, but there's a theme to these problems after you watch the videos or do a few. Create a model and just think through the problems a little bit, and I think the table will help you. Even though I didn't notice that I didn't fill in the probabilities, so it's just more of a guide to think through the questions. Okay, I hope that helps.